So I'm going to do brief answer keys, video answer keys for each of these for each of the problems on the practice, just so that we can kind of hopefully address any questions that students are having. Now, in this first example, we have HNF2, and we've actually given you the structure. We just have to figure out how many bonds to draw and how many electrons to work with. So what I'm going to do is the first thing I have to do is go ahead and figure out how many valence electrons I have. So I'm just going to do this over here. So I have nitrogen, and I have hydrogen, and I have fluorine. Nitrogen there's one of them in the problem or in the formula, and it has 5 valence electrons. So hydrogen, there's one of them in the problem, and that has 1 valence electron. And fluorine, there's 2 of them in the problem. They each have 7 valence electrons for 14 valence electrons. We add all that up, it comes out to 20 valence electrons. And then the first thing that I do when I do these problems is I give a single bond to everything and subtract. So 6 leaves me with 14 electrons to find a home for. So then the next thing that I do is I go ahead and I start adding pairs of electrons where they're allowed. And the first thing I want to point out is that the common mistake that students were making, at least in some of my classes this morning, was they were adding electrons to hydrogen over here, and you just can't do that. You have to remember that hydrogen can only have 2 electrons. So that'd be like a bond. So like hydrogen with that. So that bond is the 2 electrons that hydrogen can have. So I can't add any electrons to hydrogen, but I can add electrons to nitrogen and fluorine. So I'm going to go and start adding my remaining electrons. So I've got 14 left to place. So 2, 4, 6, 8, 10, 12. Okay. And so the only other place I have to go is on nitrogen. And again, I'm going to go back and check. So fluorine has 1 line, 1 dash, so that's 2 electrons, plus 6 dots, so that's 8 electrons. The other fluorine has 1 line, 1 dash, that's 2 electrons, and 6 dots, so that's 8 electrons. And nitrogen has 3 lines, so that's 2, 4, 6 electrons, and 2 dots, so that's 8 electrons. And then hydrogen has its 2, so it's in good shape. The next thing we need to do is we need to go and identify whether or not we need to draw dipole arrows and partial charges. So there's really only 2 types of bonds here. There's a nitrogen and a fluorine bond. And so I'm going to try to figure that out. So nitrogen and fluorine. So I'll do that one first right away, get that squared away. Nitrogen's electronegativity, according to the periodic table, is 3.0. And fluorine's electronegativity, according to the periodic table, is 4.0. So when I subtract those out, I get a value of 1.0, making this a polar bond. Okay, and we'll deal with that in a minute. We then have the other type of bond, which is between nitrogen and hydrogen. So here I have my nitrogen and my hydrogen, which, if I go to the periodic table, I see that nitrogen has a 3.0 and hydrogen is a 2.1. And when I calculate the electronegativity difference here, I get a, 0.9? So it's also a polar bond. So now I have 2 polar bonds, which means I do have to draw dipole arrows and assess partial charges. So I always draw my dipole arrow toward the more electronegative element. So in this case, for the nitrogen and the fluorine, I'm going to draw towards fluorine. And in the case of nitrogen and hydrogen, I'm going to draw towards nitrogen. So let's do that right away. So here I'm going to draw one that looks like this, and I'm going to draw one that looks like this, and I'm going to draw one that looks like this. And then the other thing that we have to do is we have to use the dipole or the partial charges. And the partial charges are, if it's the negative partial charge, it goes toward the more electronegative. So this side would be delta negative and this side would be delta positive. And down here would be delta negative and delta positive. So on my structure, I have delta negative on my fluorines and delta positive on my nitrogen. But then on my hydrogen, I have delta positive and delta negative, because we're talking about the bond and not just the atom. So that's the answer and the work associated with the first practice problem. I'll be making videos for the remaining 5 as we go along. And if you have any questions, please don't hesitate to ask.